Alright, here we are for lesson 15 in Unit 4, the slope of a non-vertical line. So the materials you're going to need are a transparency, that's optional, and graph paper is optional also. Alright, for our opening exercise, go ahead and complete the example before continuing the video. Alright, you should have the opening exercise completed. So, describing which graph is steeper, you might say that graph B is steeper. And then write the directions that explain how to move from one point on the graph to the other for each of graph A and graph B. Well, if you notice for graph A, if you move 2 units up, 1, 2, and 2 units to the right, then that seems, or 3 units to the right, sorry, then that seems to be how it's moving. For graph B, you could be moving 4 units up and 3 units to the right. And then for part C, write the directions from part B as ratios and then compare the ratios. How does this relate to which graph was steeper? And actually the points crossing are here, so 2 up and 3 over. So this would be 2 over 3, and this would be 4 over 3, and 2/3 is less than 4/3. So that's why graph B is steeper and because it has a greater ratio. All right, let's take a look at pair 1 on your lesson worksheet. You're looking at the graphs in pair 1, which graph is steeper and how can we prove it? Write the directions that explain how to move from one point on the graph to the other for each of graphs A and B. First, we want to find an intersection of grid lines where the graph lines intersect also. In graph A, it is at point -4, -5. So right here. I've gone ahead and highlighted it. Next, we want to find the intersection of grid lines and the graph line again, which would be at 1, -1, which is right there. So what is the change from the left point to the right point in terms of moving along the horizontal and vertical grid lines? Again, this is a translation. Well, we would be moving 5 to the right and 4 up. So therefore, for every 5 units of distance, the elevation rises 4 units. Since elevation is dependent on distance, we write the relationship as a rate of 4 over 5. So we go 5 to the right and 4 up, but again, we write it as 4 over 5. We can also write this change in elevation as a unit rate. If we have 4 to 5, or 4 over 5, then what would that be as a unit? What is the elevation as we move 1 unit in distance? Well, that would be cross multiplying. 4 times 1 is 5x, and x is 4/5. So to go from one grid line to the next is the same as if we went 1 grid line. For every 1 unit of distance, the elevation changes by 4/5 of a unit. So here is 1 unit of distance, and then we go up, and that is less, as you can see where the graph line is crossing, it is less than 1 unit, which would make sense that it would be 4/5. So this would indicate our 1 unit, or unit rate of steepness or elevation. All right, let's take a look at graph B. I have gone ahead and marked where the line intersects at grid lines. So the two coordinates on the intersecting lines are -4, -5, and 8, -4. So what is the change in elevation? Well, it would be 12 to the right and 1 up. So how would you write this as a rate? Well, we would write it as 1/12. So what is the unit rate for this? Again, it is also 1/12. And what does this mean? Well, again, for every 1 unit of distance, the elevation changes by 1/12. And so here I've marked it on the graph. So which graph is steeper? We can compare the rate of change for each graph. Graph A was 4/5 and graph B was 1/12. Well, we can decide by just setting up a proportion that 4 times 12 is greater than 5 times 1, because the common denominator of 5 and 12 is 60, so that becomes our common denominator. Well, then 48/60 is greater than 5/60, so that's why 4/5 is steeper than 1/12. And here we have it. Graph A has a greater ratio and is steeper than graph B. All right, pairs 2 through 4. Go ahead and use the same process to prove which graphs are steeper. Continue the video when you are finished. All right, you should have pairs 2 through 4 finished. And go ahead and compare your answers with what is presented here. If you have any questions, please make a note and bring your questions to class. Here is pair 3 and pair 4. All right, into your journal, let's do example 1. You're going to sketch these next graphs in your journal. You don't need to be detailed about numbering, any grid lines or units. We're just going to talk unit rates in general. It might be helpful to have a ruler if you are concerned about straight lines. So putting horizontal lines off to the side for a moment, there are 2 other types of non-vertical lines. Those that are left to right inclining, as in the graph of L1, which I'll show you, and those that are left to right declining, as in graph L2, which I will show you on the next slide. So go ahead and sketch these out. Again, they don't have to be on actual grid lines because it doesn't really matter at this point where these are intersecting. The fact that one is inclining and another is declining is all that is important. So we want to use a number to describe the amount of steepness or slant that each line has. The definition should be written in such a way that a horizontal line has a slope of 0, that is, no steepness and no slant. So we begin by stating that lines that are left to right inclining are said to have a positive slope, and lines that are left to right declining are said to have a negative slope. We will discuss this more in a moment. So here is example 2. Let's look more closely at finding the number that will be the slope of a line. Suppose a non-vertical line L is given in a coordinate plane. We let P be the point on the line L that goes through the origin. So if you notice, P is marked where the origin is. So next we can locate a point Q that is exactly 1 unit to the right of P. Now again, depending on how your grid is set up, 1 unit could be anything, hence the reason why we don't have this marked with any units. So let's just say for our purposes that the distance between P and Q right now, which is indicated here, the distance between P and Q is 1 unit. So next we're going to draw a line, L sub 1, through point Q that is parallel to the y-axis. The point of intersection of line L and L1 will be named point R. So here we have point Q and we have point R. So the slope of the line L is the number that we're going to assign M associated with the y-coordinate of point R. So wherever this intersects here, what is that y-coordinate that is occurring at that intersection? The question remains, what is the number? So think of L1 as a number line with point Q as 0. Then however many units R is from Q is the number we are looking for, the slope m. Another way of thinking about this is through our basic rigid motion translation. We know that translation preserves lengths of segments. If we translate everything in the plane 1 unit to the left, so that point Q maps onto the origin, then the segment QR will coincide with the y-axis, and the y-coordinate of point R is the slope of the line. So let's go ahead and demonstrate that. So here I have my graph, and again I've just arbitrarily identified what 1 unit is going to be. So using our basic rigid motion, if I slide the coordinate 1 unit to the right, notice that my y-axis now intersects at what would be called point M. And wherever this is on the y-axis, that is going to be our altitude, and therefore the steepness of our line. All right, so let's go to example 3. Suppose a non-vertical line is given in the coordinate plane. As before, we mark a point P on the line and go 1 unit to the right of P and mark Q. Before we go any further, can you know why we use 1 as our unit? Well, because that is our unit rate. And that tells us that for every 1 unit, doesn't matter how many units we go over, the rate is always going to be the same. So that is why we always go over 1 unit. So what we've done is move 1 unit to the right of P, and we've marked point Q. Then again we draw our line L1 through point P that is parallel to the y-axis. Again, why is it parallel? Because it's our translation of the y-axis that we are actually doing. So we mark the intersection of lines L and L1 as point R. Again, recall that we consider line L1 to be the vertical number line where point Q is at 0. Then the number associated with the y-coordinate of point R is the slope of the line, which we're going to call M. All right, so let's take a look at this one. So again, I have my declining line, and again I've marked an arbitrary length of distance of 1 unit, and then as I slide or translate the coordinate plane over to that 1 unit, notice where our intersection is. It is obviously below 0, which means it is negative, and that is why we get a negative slope. So wherever this intersection is going to be M, and that is going to be the amount of steepness of our decline. All right, let's take a look at example 4. Now we have a line L that does not go through the origin of the graph. So how are we going to handle that? Well, our process for finding slope changes only slightly. We will mark a point P at any location on line L. Other than that, the work is going to remain pretty much the same. We will go 1 unit to the right of P and mark point Q. The line through P and Q, which is parallel to the x-axis, is L1. Then we're going to draw a line through Q parallel to the y-axis. We will mark this intersection of lines L and L2 as point R. Again, recall that we consider the line L2 to be a vertical number line where point Q is at 0. Then the number associated with the y-coordinate of point R is the slope of the line, M. Just as before, we translate so that point Q maps onto the origin and the segment OR coincides with the y-axis. So let's go ahead and demonstrate that. So we have our graph of a line that does not go through the origin. So what we would end up doing is translating our coordinate axis up to where the line does look like it is going through the origin. Once we've done that to make to make the line go through our supposed origin, which has been translated, now we can move along that parallel line 1 unit to the right. And so therefore the steepness of the line is measured from this being point 0 to wherever this is intersecting. So let's demonstrate that again. We take our coordinate grid and we move up so that it does create the line going through the origin. And then we proceed as before. Now we just move along that parallel line, and that determines our steepness because it is still going through the origin from here to here, but as we move, we can now determine the steepness of the line. So what is the slope of this line? And here is another example. If you want to stop the video and sketch it out, we actually have numbers and grid lines so that you can determine what the slope of this line is. Well, the slope of the line is at 1.5, or that is, m is equal to 1.5. So in general, we describe slope as an integer or a fraction. Given that we know the y-coordinate of r is at 1.5, how can we express that number as a fraction? Well, the slope of the line is 3/2, that is, m is equal to 3/2. All right, now it's your turn. Exercises 1 through 6. Go ahead and complete those. If you want to use your transparency to help you do that, you can. Check your answers after each problem. All right, so you've done exercise 1, and this is what you should have. The slope of the line is 4, so that means m is equal to 4. All right, if you're done with problem 2, you would have the slope of the line is 3, and therefore m is equal to 3. And which is steeper? Well, graph 1 seems steeper. The slopes are 4 and 3, and it seems like the greater slope is the steeper line. Here is for problem 4. The slope is -1, so m is equal to -1. And for 5, the slope is -4, so m is equal to -4. And for number 6, since there is no steepness or incline to this line, that means our slope is 0. All right, let's take a look at example 5. We're going to take another look at one of the proportional relationships that we graphed in lesson 11. Here's the problem and the work that we did. Pauline mows a lawn at a constant rate. Suppose she mowed a 35 square foot lawn in 2.5 minutes. So as a table, this is how we would set it up. Go ahead and sketch this out before continuing. All right, you should have your table completed. Now if we assume that the points we plot on the coordinate plane make a line, and we have an origin of the graph is a point, then we have something that looks like this. So point P is at our origin, and then we have 1, 14, 2, 28, 3, 12, and 4, 56. Go ahead and sketch this on graph paper and continue when you are finished. Right. So what is the slope of this line? Well, 1 unit to the right of P is point Q. That makes the point 1, 14 the location of point R. Therefore, the slope of this line is 14, or m equals 14. So what is the unit rate of mowing the lawn? Well, Pauline's unit rate of mowing a lawn is 14 square feet per minute. So again, tying back our graph and our table to the context of the problem to identify the unit rate. So when we graph proportional relationships, the unit rate is interpreted as the slope of a graph of a line, which is why slope is referred to as a rate of change, or a rate of change of elevation. All right, so let's wrap this up. We know that slope is a number that describes the steepness of a line. We know that lines that are left to right inclining have a positive slope, and lines that are left to right declining have a negative slope. We can find the slope of a line by looking at the graph's unit rate. All right, we'll see you in class.